All right, we're live. And for today's lesson, we're going to be doing a review of the two methods of estimating products, which is rounding and compatible numbers. If you recall, and I'm just jumping to the slides from yesterday, if you recall, rounding is when we change factors to the nearest multiple of 10. Whereas compatible numbers is changing factors to a number that's close to your original factors, but not necessarily a multiple of 10. And both of these methods are acceptable for whenever you're doing estimation, but ultimately you want to use the one that will give you the absolute closest product, right? You don't want to change your factors too drastically because the product you get is going to be way too much of an overestimate or way too much of an underestimate, and we don't want that. We want to get as close to the actual answer as possible while still doing mental math. All right. So with that in mind, I'm just going to jump around and we're going to try a new problem today. So for today, William used rounding to estimate 243 times 4 and found 200 times 4. Mateo used compatible numbers and found 250 times 4. The actual product is 972. That's what when you multiply 243 by 4, you should be getting 972. So looking at what they changed their factors to using rounding or compatible numbers, whose method do you think will give an estimate that's actually closer to what the product should be, the actual answer, 972? Do you think that William using rounding or Mateo using compatible numbers was the way to go? Take a minute to see how they change their numbers, and I would love to hear your input. Okay, I see Jordan's hand up. Who do you think would get a closer number?
Are you talking to me?
Yes, Jordan, thank you.
Actually, it's Mateo.
You think that Mateo got a closer number? Who agrees with Jordan that Mateo would have a closer estimate? He's supposed to get an actual answer. So when we do 243, our actual, well, I won't write it again, but our actual number should be 972. That's our goal. So we have 243 times 4, which we don't want to solve the long way. We just want to get an estimate. We're not finding the actual product. Now with rounding, maybe I can do this with 2 different markers here. Let's see. With rounding, we had new numbers here. We got 200, right? I just want to make sure I have it. 200 times 4. And with compatible numbers, I'm going to use another color. We got 250 times 4. Okay, so I'm just going to stop sharing so we can see how we're doing this. Just quickly, does anybody know which room Dominic is supposed to be in? Blue?
Blue.
Okay, I'm moving him there now. Alrighty, so that being said,
he's supposed to be in our group.
Okay, well, I entered him, so he should be here. So can everybody see my board? I'm gonna pin my video. All right, can everybody see my whiteboard? If not, I'll try and shift it so that you can see it a little bit better. But
no glare.
Yes. So here is our actual problem, 243 times 4. We can either round or we can use compatible numbers. And compatible numbers, I'm just going to put comp numbers, right? Compatible numbers just means we're changing it to a number we like, right? We're changing to a number that we can multiply very easily. So with this in mind, everybody want to make sure you can all see that. No glare, okay. So with this in mind, our first problem, we rounded 243 to 200. How did we do that? Well, we looked at 243 and we want it to be a multiple of 10, because when it's a multiple of 10, we can use our trick where we box our basic facts and add our zeros, which we did in the last lesson. Do you remember that? Right now, I can't box my basic facts because 243 is not a basic fact I know. 4 is a basic fact. That's a times table I know, so I don't need to change. If I already have a basic fact, I don't need to change it. I keep 4 as 4. I keep 4 as 4. But 243, I want to round it to either a multiple of 10, 100, or 1,000. In this case, we're looking at 243 and we're deciding, is it between, I'm sorry, which hundreds are it between? It's between 200 and 300, yes? So it's between 200 and 300. Those are the two numbers that it's between that are multiples of 100. How did we decide that it was 200 when we rounded it? Chris?
Because it said 5 or more raise the score, 4 or less let it rest, and that is not a 5 or higher, that is a 4.
Right. So we look at the place we're rounding to, and we're rounding to hundreds, right? We want to the nearest hundred. So here's the hundreds place. We look next door and we decide, is this a 5 or more or a 4 or less? 5 or more, raise the score. We're going to say that it's close to 300. 4 or less, let it rest. We keep it at a 200. In this case, as Chris just said, we are indeed going to be making this into, rounding this to a 200. Does everybody see that? 243 is closer to 200, not 300. When we round it, now we have a beautiful answer that we can use our method that we learned in the last lesson, which was to box your basic facts. 2 times 4 is 8. And then count your zeros, 1, 2, 1, 2. So our first estimate will give us 800. When we use compatible numbers, we were looking at it and we're saying, 234. I don't want to round it because when I round it, it's probably going to give me a pretty big answer. What don't I try finding another basic fact that I know that's super close? Oh, well, if I'm looking for basic facts here, I know that I'm using my 4 times table. What can I change 234 to that would be easy to multiply? Well, since I'm going to be boxing my basic facts, 234 will actually change to what, Kayla?
Well, it's two, it'll change to 250, but the numbers are different.
And they're supposed to equal the same thing, so why did you switch the 3 and the 4?
243.
Oh my gosh, I'm so sorry. Thank you. 43 is what I meant. Thank you so much. I apologize. Good call. Good catch. Good catch. All right, so 243, we would switch it to 250. Why? When we're doing our basic facts, what would we be boxing here? What would we be boxing? Looking for a hand? Looking for a hand? Helping hand? Ashley, what would we be boxing? I can't hear you. You're muted.
We'd be boxing 24.
Right, we would box a 24 here, but 24 is not something that multiplies easily with 4. So I thought to myself, I know that I actually can multiply 25 by 4 super easily because I know my 25 times table. But this
I
is
know
not
the
actually,
answer.
okay, awesome. Well, let's just take a look at this first and then I'll get right to you, okay? So
Okay.
we changed our 24 to a 25, but it wasn't really a 24, it was a 243, so we have to change this to a 250. Either way, we're left with a basic fact that we know and just a 0 we have to carry over. So go ahead, give us the answer now. What do we have to do?
We'd have to, so technically do 5 times 4. I mean
Why?
25 times 4,
Mhm.
which would equal, let me think. I forgot the answer.
Anybody? What's 25 times 4, Emma?
100.
100. And I'm putting that in my box for reasons I've explained, right? When we put in our box, we make sure we don't accidentally miscount our zeros. Count the 0 that's left over, 1. So these are our two estimates. When we rounded our factors and multiplied them, we got 800. When we used compatible numbers, we got 1,000. If our actual answer, 243 times 4 equals 972, which of these methods was the better method to give you a more accurate estimation, a closer estimation? Which one would work best? Kai, which method?
Wait, for the question, did you say 24 times 5? Because if you did,
25 times 4.
25 times 4.
Oh,
But
okay.
could you let us know while we have you
No, because
here?
I thought
Which one of
you said 24 times 5.
Oh.
And I was like, wait, that equals 120.
Oh, no, 25 times 4. Which of these methods would be the better way to get a closer answer to our actual? Which one will give us a closer estimated product? Chris?
Compatible numbers.
Compatible numbers, right. If we're supposed to get 972, 1,000 is closer to 972 than 800 is. So even though both methods will work for estimating, ultimately, we want to pick the method that's going to give us the closest to our actual product. And in this case, compatible numbers does that, because if you look at how you change your factors, look at the numbers we changed it to. We changed 243 to 200. We changed 243 here to 250. If you look at the difference here, remember that multiplication is repeated addition. So 243 times 4 means that we're adding 4 243 times. When we rounded, we added 4 200 times, which means that we needed to multiply it 43 more times, right? With compatible numbers, we were supposed to multiply 4 243 times. Instead, we multiplied it 250 times, which means that we are about how much off? How many times more did we have to multiply? How many times less did we have to multiply?
7.
Right, so this is 7 times, this answer is 7 times less, right, than what we should have been having. This answer is only 43 times less. This one is 43 times less. So do you see how this answer is closer, this product is closer than using the rounding method? So returning to our problem, this is exactly what we just did on our board. We rounded 243 to 200, kept our 4 because it was a basic fact. You don't round or change your basic facts, you keep them as is. And we got a product of 800. When we had compatible numbers, we saw that, well, 243 would probably use that basic fact of that 24, which is not really a basic fact. So I changed it to a 25 and added on my 0, and I multiplied 250 times 4 and got 1,000. And 1,000 would be a closer estimate because I didn't change my factors, my original factors, by too much, whereas with rounding, I decreased my 243 to a 200, which was a huge leap of 43 times difference there. All right, so when we're doing all of these problems, I want to make sure that you always have your math notebook out. So we're about to do some practice problems together, including the practice problems that we just showed, but we're now going to do some guided practice. You should be working in your math notebook. You should be showing all of your steps, including the same way I have it on my board. I want all steps written out, all procedures nice and neat and organized. You should be using a pencil because in math, we want the ability to erase mistakes. You should never be crossing out mistakes, scribbling out mistakes, because that makes our math unorganized. It makes it unclear, and that's how we get careless errors, which is the biggest downfall in math. That's the biggest error I see are careless ones with unorganized work. So these problems are directly from your textbook. The ones that I've put here, I've selected them. They're numbered a little differently on my screen, but so that I can work primarily from the whiteboard, I'm going to ask you to follow along in your textbook. So the first question on there correlates with number 7 on page 69. So I'm going to exit through my screen so that we can work and focus on the whiteboard here, and everybody can hopefully see that. So whiteboard, screen. I'm going to erase. So I'm keeping these methods up here because you need to decide for me. I'm going to ask you, should we use rounding or should we use compatible numbers? And again, you're looking for what works for you, and you're also looking for which of these methods is going to give me the absolute closest to my actual answer. Yes, Ashley? I can't hear you, sweetheart. You're muted.
Yeah, I know. Wait, what was it? Never mind.
All right. So number 7 in your textbook says 75 times 28. That's our original number. 75 times 28. Can everybody see? That 7 is a little too close. See, even I need to erase because I want to make sure my work is as neat as possible. 75 times 28. Now, since these two factors are not basic facts, I'm going to want to change them. Either I want to change them to a multiple of 10 so I can use my boxing trick and add my zeros, or if I'm looking at the two factors and I see another basic fact times table that I can alter them to, I may want to use compatible numbers. Does anybody see in these two factors something that we can change to make them easier? Do we see anything we can change? Okay, Izzy?
We can change the 75 into a 80.
Okay, so what I'm gathering is we may be leaning towards rounding, because unless you see something that, another factor that I can change here, a basic fact, you can eye on any basic facts, we're probably going to want to use rounding for this problem. So let's check off rounding, because this is the method we're going to use. And with rounding, we're looking for the nearest multiple of 10. So 75, what are the two multiples of 10 that 75 is between? And we can unmute ourselves for now so that we can, without screaming, because remember we have a microphone on our devices, so our voices are already super amplified. You can just speak in a low, calm voice instead of shouting out.
That's what I got.
But all of you, what two multiples of 10 is 75 between? What is it between?
80 and 70.
Right, it's between 70 and 80. Let's use our trick. Underline the place that we're rounding. We're rounding it to the nearest 10, so I'm underlining the tens place. Look next door. 5 or more raise the score. It goes up to an 80. 4 or less, let it rest, it stays a 70. Which one? We have a 5. So will this 75 be changed to an 80 or will it stay a 70? Go ahead, shout it out. Not shout, but
80.
80.
thank you. It will go to an 80. That is the closest multiple of 10. And that'll be easy because I see my basic fact right here is the 8 times table. All right, the same thing. I want to, what 2 multiples of 10 is 28 between?
30 and 20.
30.
Izzy is on point today. It's between 20 and 30. I'm going to underline my 2, look next door, and I have an 8. Remember the rule. 5 or more, raise the score. 4 or less, let it rest. Is 28 going to raise up to a 30, or are we simply going to bring it to a 20, which is our close, which is one of our multiples of 10? Which one would we select? Is it raising up? Yes, it's close to a 30. So I'm going to change my 28 to a 30. And notice without even thinking about it, I automatically started boxing my basic facts. That's the times table that I know, 8 times 3. All right, let's see if you know it. 8 times 3, everyone, is?
24.
24.
24.
I'm going to box my basic facts
And then add 2
and
zeros.
count the zeros. 1, 2, 1, 2. So our estimate, good. So our estimate, so I see a few extra zeros in your message there, Sebastian. We have, right, we have to, that's why I draw it out. So I make sure I don't have too many zeros because that'll make my whole answer wrong. I do the silliness of counting my zeros and adding in there. So you see how we got that, right? Okay, so 2,400 is my estimate. Did anybody see anything? So looking at our factors, we were supposed to multiply by 75. We increased that factor to an 80, right? I'm gonna mute, guys, we need to be muted unless, right, if we're gonna have background noise, we need to make sure that we're muted until we're sharing. So with this problem, we increased our factor of 75 to an 80, and we increased our 28 to a 30. So is our estimate our final product for our estimate going to be greater than or less than what we should be getting, than the actual? What do we think? Look at how we changed our factors. Is it going to be greater or less than Jaden?
I think it might be greater, but I'm just not sure.
No, you're absolutely correct. It will be greater. Why? We were supposed to be multiplying by a 75, and instead we multiplied by an 80.
Oh wait, that's right, because
So
80
look, we're using a larger factor than what we're supposed to be using. And here we started with we were supposed to be multiplying by a 28, and we rounded it up to a 30. So the product that we have is going to be larger than what the actual product should have been. What do we call that when our product is larger than what it should have been? What do we call that? We said it yesterday. Kai?
An overestimate. And
It
then
is an
the other
over.
one. Wait, can I see the other one?
Sure. Well, first explain it. You can't just say the word. What's the other one?
The other one is an underestimate, and an underestimate is when you estimate and it's under the actual answer.
Exactly. So if
it
my
would be an
factors,
underestimate.
right, if I made my factors smaller than what they originally were. In this case, both factors were made larger, right? 75 went to an 80, 28 went to a 30. So we were multiplying by a greater amount. So this product is going to be an overestimate because it's going to definitely give me a product or an answer that's bigger than if I had just multiplied it the good old-fashioned way using the standard algorithm.
Okay.
Awesome. Thank you, Kai. So let's try another one. We're going to look at number 8. And I hope you have this entire sample with all of the work down in your notebooks. For those that are chatting, I am sharing the screen. So when your parents view this video, they will see that you are having a conversation with one another during class. So please do not abuse the chat box. The chat box is for questions or for sharing responses. So thank you very much for not abusing that. All right, let's move on. We're on number 8, 3 times 118. And actually, I'm going to move it over here because I see 2 ways to do this. That other problem, I couldn't really see a way to do it with compatible numbers, although it really depends on how good you are with your 75 times tables, because some of you may have known your 75 times tables, so you might have used that for your compatible numbers, maybe. All right, so 3 times 118. We are going to do what with the 3's? No matter what method we choose, what do we know about the 3? Merrick, what do we know about the 3?
We you know that we will probably be doing 118 3 times.
Right.
Instead of 3.
Now, what about, I'm talking about like if we're doing rounding or compatible numbers, what do we need to know about the 3?
Well, I say we'd probably not like round it up or down.
Exactly. We're not doing anything with it. We're keeping it, right? We're keeping the 3 as is because it is a basic fact. You don't want to change a basic fact. It's a times table you already know. So there's nothing, it's untouchable. Leave it the way it is, right? The 3, don't say, oh, you know, I'm going to change the 3 to a 4. We're not rounding it. We're not finding a compatible number because you should know your 3 times table by heart, okay? So I'm going to bring those numbers down in each of my methods. I'm keeping the 3, and the number I really want to focus on is the 118 because the 118 is not a times table I know. Now, you may have already seen this, but both methods will work for 118. We could either round it or, hopefully, if you're looking very closely, you see something a little bit closer in 118 than the rounded version. So let's start with rounding. If we're rounding 118, we're looking at the hundreds place, yes? And in our hundreds place, we have a 1. So what are the 2 multiples of 100 that 118 is going to be between? Jaden?
So one of them would be 100.
Right, 100.
Another one would just be 2 plus, which would be 120.
Right, it could be 120. That would be rounding it to the nearest 10. So you can either do the nearest 100. I'm going to round it between 100 and 200. Or I can round it between, well, we'll save that for that one. But usually you're picking the highest place value when you're rounding for something like this. The other method, bear in mind the 120 you just said, okay? So we can either do between 100 and 200, which will make it, when we round it, it would be what?
200.
118. Is that closer to 100 or 200? Look next door.
100.
Look next door. There's a 1 next to it. 5 or more, raise the score. 4 or less, let it rest. So it would be a?
100.
100. And then box your basic facts. 3 times 1 is 3. 1, 2, 1, 2. So our estimate was 300. Or as we just, I forgot who shared. Who just said between 100 and 120? That was you, Izzy?
I didn't say it, but I had a different problem and I rounded it to 120 and then I got a different answer more than that.
So if you rounded it to 120, that means instead of rounding it to the nearest 100, you rounded it to the nearest 10. So let's round to the nearest 10. We have 3 times 118. We keep the 3. Can everybody see at the bottom of my board? We keep the 3. And 118, if we're going to the nearest 10, is between 110 and 120. Does everybody see?
20.
And that means since you're rounding it to the tens place, you look next door, 5 or more raised a score, it would move on to a 120. Does everybody see how you can round it to the nearest 100 or the nearest 10? As long as you know this basic fact. Because let's say it was 130 and you don't know your 13 times table. Then I want to round it to the nearest 100, not the nearest 10. But I know my 12 times table, so I'm going to box my basic facts. 3 times 12 is?
36.
36. Box it. Count my zeros and we get 360. So these are 2 options that you had, because when you round, you're rounding to the nearest 10, 100, or 1,000. Okay? Those are your options to round. Compatible numbers. How could I have changed the 118 to a times table that I knew? How can I change the 118 to a times table I know? Jaden?
Just rounded to 120, and then I had a way that you could have done it. This is an easier way for me. You could just switch the 118 around with the 3, and then you would get like 120, and then it would probably be much easier.
Right. Right. You could, we did 120 down here. Did anybody see when they did their basic facts, a 3 and an 11? You could also, and some of you are saying, but 118 is closer to 120. Yeah, but we're not using rounding anymore. Now we're using compatible numbers. So I can change it to any number I want that's close to 118. So I could have just kept the 11 because I know that basic fact. Do you see what I'm changing it here? 11, put it in our box for our basic facts. But remember, it's not really an 11. It's 118. So I'm going to change it to 110. Basic facts, 3 times 11 is 33. Carry the 0 over to have a compatible number estimated product of 330. So we have 3 different possibilities here for your estimation, right? We have 300, 360, 330. Which of these options do you think is the closest? And you determine that by looking at what you changed your factors to. This factor, we had 118 and we changed it all the way to 100. This factor, we had 118 and we increased it by how many? Just 2, right? 118 to 120. So it's 2 times greater than what it should have been, yes? And this set, we did 118 to 110. How much did we change it by here? I see Jaden holding up fingers. How much did we change it by here from 118 to 110?
7.
By 8, right? It's 8 more. I'm sorry, it's 8 less. So this is 8 less, which means that this is going to be an underestimate by 8 times less.
Yeah.
This changed from 118 to 120, meaning it went up. So it's going to be an overestimate by how many? 2 times greater. And This is going to be, wow, we dropped all the way from a 118 to a 100. Do you see this? So this is probably not our best option, right? We decreased our factor by 18. So the 3 should have been multiplied 18 more times. Which of these 3 is the best? Which of these 3 is the best? Which would you choose? Go ahead, shout it out. Which one do you think?
120.
The second one.
This 3 times 120?
second one.
I agree. That's going to be the absolute closest option. But all of these are acceptable. All of these would be considered correct because when you're estimating, the whole object of that is to be able to do mental math, and you should be able to do 3 times 100 in your head. You should be able to do 3 times 110 because you have the basic facts of 3 times 11 there in your head. You should also be able to do 3 times 120 in your head because you have the basic facts of 3 times 12. Does everybody get that?
Mm-hmm.
All right, so we're going to do one more, and then I'm going to let you go practice on your own. We're going to do one more to make sure that we got this. And I wanted to pick one that had 3 factors. So let's look at 16. 26 times 29 times 41. First of all, I take a glance and I see, do I have any basic facts? No, I don't. There are no times tables there that I know by heart. So I'm going to move on, and I need to decide, should I round, or is there a way that I can change my factors that's closer? Because sometimes when we round, look at that last problem we did. 118 went all the way down to 100. That's not very close, right? 110 was closer, 120 was closer for an option. Does anybody see any numbers here that maybe we might be able to change to something closer? That's a times table we know. Anyone? I'm looking for hands. We could round all of them, but does anybody see any of these factors that might be able to be changed to something a little bit closer than the rounded number? See 2 hands up. It might not be a times table you're familiar with just yet, but you should be. I see one. I see one of these numbers that could be changed to something that's a little bit closer than the rounded number. Nobody? All right, I saw Kai and Izzy were raising their hands. What do you both say? Which of these numbers?
I think 26 could go into 25.
Does everybody see that? If you should know your 25 times tables. So if I was rounding 26, I would get, I'm going to put the rounded one up here. If I was rounding 26, it would round to a 30, right? But if I know my 25 times table, why would I change it all the way to a 30 when I can just decrease it by 1 and use the 25 times table? How many of you know your 25 times tables? Remember I showed you there was a pattern? 25, 50, 75, 100, then 125, 150, 175, 200. So it's always 25, 50, 75, 100. Then it's 125, 150, 175, 200. Then 225, 250, 275, 300. Do you see how it follows the same exact pattern over and over? So you should know your 25 times table by heart. If not, now you do. So you could have changed it to a 30 or a 25. If I were you, if it was me doing it and I want to get as close as possible, I would 100% go with the 25 because it's only changing my original factor by 1. 29, should we round it or should we use a compatible number? Shout it out.
Round it.
Round it. Why? Because 29 is going to round to 30, isn't it? 29 is going to round to 30. So why would I try and find another number when it's already only 1 away? And then 41, round it or compatible numbers?
Round it.
Round it because it's going to change to a 40.
40.
And that's only 1 off. So either I can do 30 times 30 times 40 or 25 times 30 times 40. Those are my two options. Does everybody see how to do that? And then you would box your basic facts and solve it. Does everybody get how you can use two different methods between rounding and compatible numbers? Are we all familiar with it now? Is there any one way that's better? Not necessarily. You can use both methods, but the goal is you don't want to be so far above or below your actual answer that your estimate is really pretty invalid. So we want to make sure that our estimate is as close as possible. All right, guys, so I will dismiss you. I want to make sure that you have your practice problems for today and that you are writing all your steps, you're boxing your basic facts, and you're trying out the method that works best for getting the closest to your actual answer. All right, guys, see you.